Standard position. An angle is in standard position if its vertex is at the origin and its initial side is along the positive axis. Okay. A lot of the times in this class, we're going to have angles drawn in the coordinate plane. And so when the initial side is on the x-axis, like we're saying, and the vertex is right here at the origin, this is going to be standard position for an angle. Okay. So that would be like in contrast to geometry when you just had some picture and you had an example of an angle right there. That's an angle, but that's not in standard position. So our standard position is going to be when it's placed on the coordinate plane. Okay. So this angle, I don't know what the measure is, maybe 60 degrees or so, but it happens to terminate in the first quadrant. It's going to be kind of important that we look for the quadrants throughout the semester and what quadrant we end up in with our angle. So here's another angle in standard position. You've got your initial side, you've got your terminal side. I don't know what the angle measure is. I know it's in between 90 degrees and 180 though, right? So it's somewhere in between 90 and 180. I can tell that this terminates in the second quadrant. Quadrantal angles. Angles in standard position having their terminal sides along the x-axis or y-axis, such as angles with measures 90 degrees, 180 degrees, 270, 360, keep going, 450, and so on and so on and so on. Okay? Think about what the word means. Quadrantal angles. Quadrant angles. Okay? We're talking about the angles that make the four quadrants. So when you look at your coordinate system and your x and y axis, any angle that ends up lying on the axis, like a 90-degree angle, that would be a quadrantal. 90 to 180 or 270 or 360. Basically, we're talking about multiples of 90, right? Multiples of 90 degrees are called quadrantal angles. A complete rotation of a ray results in an angle measuring 360 degrees. By continuing the rotation, angles that measure larger than 360 degrees can be produced. Such angles are called coterminal angles. I think that definition is a little bit difficult to understand. Okay, so let's kind of parse the language here. When they talk about terminate, ends, that's where it ends. Okay, and so when they say coterminal angles, it's going to be two angles that end in the same place. Okay? We're talking about in the same place. Two angles are coterminal if they end up in the same place. And they tried to draw a couple of pictures. Let's look at this one. In blue, they drew a 60-degree angle. That 60-degree angle terminates in the first quadrant, we can tell. But then in red, they drew another angle. And so the initial side is still on the x-axis, but what they've done is they've gone all the way around 360 degrees, plus I guess 60 more degrees. 360 plus 60 is 420. And so I'm not trying to say that 60 equals 420. Those two numbers aren't equal. We know those two numbers aren't equal. But what I am trying to say is those two angles end up in the same spot. They both end up in that first quadrant, right? And so your 60-degree angle and your 420-degree angle, they are coterminal, meaning they end up in the same place. Okay? So then the second example, you've got 110 degrees right here in blue, and that puts us in the second quadrant. And then in red, they said, well, let's go all the way around, that's 360. Let's go around again, that's 720. And then 110 more makes 830. And so I'm not trying to tell you that 110 equals 830. I'm trying to tell you that those two angles end up in the same spot. That's what coterminal means. So coterminal angles differ by a multiple of 360. Okay? Or another way of putting that, coterminal angles differ by 360 times n, where n is just some number. n could be 2. Maybe it's 2 multiples of 360.